All right, so then if we get to simple linear regression, I often call simple linear regression SLR for short, then our model is going to be something like this. So it's going to have y, that's our response variable. Then it's going to have our f of x, which is going to be denoted with these betas. So beta 0 and beta 1, these are parameters. So they are about the population, they're unknowable. But this is how we do that sort of like mx plus b. That's probably how you've seen a line written before. We're going to say beta 0 plus beta 1x. So the b corresponds to the beta 0, and the m corresponds to the beta 1. And then we've still got epsilon, that's our residuals. And then finally, we've got some notation about our residuals. I'll talk more about this, but we're saying epsilon follows a normal distribution with mean 0 and standard deviation sigma. So this is the model, this is kind of in parameter space, or the population. And then we've got another version of the model that we're going to focus on most of the time, and this is the statistic space, or the estimates. So we use y hat to mean the fitted value, and then we use hats on top of both of our betas to mean estimated beta 0, beta 1, and then we've got x in there. There's no epsilon here, so there's no error term when we're doing the estimate. The estimate is going to be different from the actual value of the response. All right, so just one more piece of notation for right now. We want to think about residuals. So residuals are kind of the observed minus expected values. And if we're thinking of that in terms of notation, that's our y sub I, our observed value of y, minus the y sub I hat, the predicted value for that particular observation. So I'm just going to draw a little picture. So let's imagine that we've got some data and it looks like this. And then I'm going to fit a model line. I'm just going to draw it. We'll say that that's it. So that's our model line. So this would be the y hat is equal to beta 0 hat plus beta 1 hat x, where the intercept is beta 0 hat, and then the slope is going to be that beta 1. So then if we are thinking about a particular point, like if I go look at this point that I just darkened in, let's call that y sub 1. Then I can think about the residual, which is the difference between the y sub 1 and the model prediction. So the model prediction is always on the line. So my model prediction would be up here on the line, and then my residual would be the difference between the observed and expected. So this is my yi hat is on the line, and that difference right here, that's the residual, that little line. That's the yi minus yi hat. And you can have residuals that are negative or positive because you're going to have points that are both above and below the line. So if we think about this point right out here, we could see what its predicted value would be. So we drop down onto the line. There is its predicted value. So that's the y, I don't know, let's see, 1, 2, 3, 4, 5, maybe this is 6. We'll say y hat 6, and this is y6. Fix that one there. And then I've got a residual for this guy as well. So that is also a residual. So we've got some points that are like right on the line, like this one. Its predicted value is exact, and so we've predicted it completely, and the residual is 0. But then we've got some positive and some negative residuals, and you could think about the residual for every single point. So if we were thinking about a positive residual, that means that yi is greater than yi hat, because when we did yi minus yi hat, we got a positive number. So that means that yi had to be bigger. And that means we underpredicted. Our prediction was smaller than our real value. And if we have a negative residual, then yi is less than yi hat, and that means we overpredicted. So you can see, for y6, as I'm calling it, in that one we underpredicted, and for y1, as I'm calling it, we overpredicted. So that's a bunch of notation. If you have questions about it, you can ask me on Teams or bring questions to one of our synchronous classes. And next up, I'm going to do an example.